But how do you actually make a qubit in practice? And how do you read and write information on it? I met up with researchers who are using the outermost electron in a phosphorus atom as a qubit. This single phosphorus atom is embedded in a silicon crystal right next to a tiny transistor. Now the electron has a magnetic dipole called its spin, and it has two orientations, up or down, which are like the classical 1 and 0. Now to differentiate the energy state of the electron when it's in spin up and spin down, you need to apply a strong magnetic field. So now the electron will line up with its spin pointing down, that's its lowest energy state. And it would take some energy to put it into the spin up state. But actually not that much energy, and if it were at room temperature, the electron would have so much thermal energy that it would be bouncing around from spin up to spin down and back. And so you need to cool down the whole apparatus to only a few hundredths of a degree above absolute zero. That way you know that the electron will definitely be spin down.
There is not enough thermal energy in the surroundings to flip it the other way.
Now, if you want to write information onto the qubit, you can put the electron into the spin-up state by hitting it with a pulse of microwaves. But that pulse needs to be a very specific frequency. And that frequency depends on the magnetic field that the electron is sitting in.
So if you just make it mutate and stop your pulse at some specific point, what you've created is a special quantum superposition of the spin up and spin down states with a specific phase between the two superpositions.
And how do you read out the information? Well, you use the transistor that this phosphorus atom is embedded next to.
The spin down has the lower energy and the spin up has the higher energy. So now, if the electron is pointing up, it can jump into the transistor.